time to review spectroscopy. We're just going to talk about two of the types of spectroscopy in this video, and they are AAS, which uses visible light, and UV-Vis, which uses UV and visible light. Spectroscopy is just an analytical technique we use to determine concentration from absorbance of light. So a quick recap of how it works is that a light is shone through a sample at a particular wavelength, and the amount of light absorbed by the substance determines its concentration. So that's the principle on which AAS and UV visible spectroscopy works. The next thing we need to do is create a set of volumetric standards that are solutions of known concentration and use them to construct a standard curve. So, for example, we were trying to determine the phosphate content of a particular solution. And so what we did is we went and we made up solutions of known concentration. We made up solutions of 5 parts per million phosphate, 10 parts, 15, 20, 25 parts per million. We then used our spectrometer to determine their absorbances. And then what we do is we plot those on a graph. So say our 5 parts was. And to create our standard curve, we just join the dots. So now that we have our standard curve, we can then get our unknown solution, measure its absorbance, and then see where that falls on our standard curve to determine its concentration. So say we went and got our unknown sample, popped it in the spectrometer, and we got a reading of 0.45 for its absorbance. So we'd go to 0.45, so 0.4 is here, so about a quarter of the way up there, and then we'd read across until we hit the line, which is just before the 20, and see where we hit on the line, and then we'd read down, and that would be our concentration in parts per million. So I would read that as 19 parts per million. So we could say that we used our atomic absorption spectroscopy and our standard curve to determine the unknown concentration to be 19 parts per million. Like all analytical techniques, comes with a few errors and limitations. So, the biggest one is that the unknown concentration of our sample needs to be within the range of our standard curve, because extrapolated results are inaccurate. There's nothing stopping us going to 30 parts per million and then extrapolating the graph to a bit bigger, so that we get a higher absorbance. So say our sample had an absorbance of 0.78. Well, that's outside the range of our standard curve, but we can extrapolate and then read down. But that means that our results are not going to be as accurate as what they would be if they were within the range of the standard curve. A few things to remember about our spectroscopy techniques is often the concentrations are in parts per million. So when you are doing your stoichiometry and you need to get your masses back to grams, always remember that 1 part per million equals 1 milligram per litre. So that's the same as 0.001 grams per litre. This type of spectroscopy can be both qualitative and quantitative in different ways. Different substances absorb different wavelengths of light. So it can give you some qualitative information about your sample by which wavelength it absorbs the most strongly at. And your quantitative information you can get is by the level of absorbance or sometimes transmittance. So absorbance is the light absorbed and the transmittance is the light that passes through, and because that is directly related to the concentration. So it'll give you a quantitative result. Okay, this is question 6 from the 2012 exam. and is a pretty stock standard spectroscopy short answer question. So let's have a read and see what it's asking us. The iron content in multivitamin tablets was determined using atomic absorption spectroscopy. The absorbances of 4 standards were measured, 3 multivitamin tablets were selected, each tablet was dissolved in 100 ml of water, the absorbance of each of the 3 solutions was then measured. The following absorbances were obtained. Let's go to part A. Use the grid below to construct a calibration graph of the absorbances of the standard solutions. Now, a calibration graph is the same thing as a standard curve. So if you remember how we do our standard curves, we just plot all the points of absorbance and concentration of our standards and join the dots. Part 2 of this question is asking you to determine the average iron content, so that's an important word, in milligrams of the multivitamin tablets. So what we first need to figure out is how many milligrams were in each of the tablets. The first thing we need to do is determine the concentrations of the tablet solutions. So it's as easy as going to your graph, looking at, so if we look at tablet 1, it had an absorbance of 0.39, going to 0.39, which would be in between those 2 there, and going across and seeing that that matches up with. Now we just repeat that for the other 2 tablets exactly the same way. Now as you can see, each of these is 0.3 absorbance units from each other. So the average is actually tablet 2. So the average of our tablets is this 360 milligrams per litre. Now it's given a concentration in milligrams per litre, and if we go back to the original information, it told us that it was dissolved in 100 mils of water. So what we need to do is factor in the dilution. So there wouldn't have been 360 milligrams in the tablet because there was only 100 mils of solution. So what we need to do is divide our answer, 360, divided by our dilution factor, which was 10. So overall there would have been an average of 36 milligrams in the tablets. Moving on, the next part is giving you a little bit of choice here. I'm going to pick the one that I think is the easiest to answer this question. So it's saying spectroscopic techniques work on the principle that under certain conditions, atoms, molecules or ions will interact with electromagnetic radiation. The type of interaction depends on the wavelength of the electromagnetic spectrum. So as you remember, each of our different types of spectroscopy use different types of radiation. So what I thought we could do is use our atomic absorbance spectroscopy, as that's what we've been using and that's what this video is about. So we'll put now atomic absorbance spectroscopy, which part of the electromagnetic spectrum does this technique use? And atomic absorption spectroscopy uses visible light. The second part of the question asks us 2 things: how this light interacts with the matter and what information does it provide. Atomic absorption spectroscopy works by using the specific wavelength of light to move electrons to higher energy levels. So those electrons get excited. And what information can it provide? Well, it can provide concentrations based on the absorbance. So that's a spectroscopy example question. What's the difference between an optimist, a pessimist, and a chemist? Optimists see the glass as half full. Pessimists see the glass as half empty. And chemists, well, they see the glass as half full of water and half full of water vapour. Thanks for watching.